Hello, and we're back with the CodeSec Days virtual conference. Today we have a really fascinating conversation that I'm really thrilled to be able to leave. We're going to be talking about defending against open source supply chain risks. So we're going to take a little bit of a deep dive. I have some questions here, a bit of doom and gloom, but hopefully we will be able to come out at the end of it with some strategy. But to help us with that, we have a really amazing guest. We have Pierre Leclisio. Pierre is the lead product manager at Guardian. Pierre, welcome and thanks so much for taking the time with us today.
Thanks, Mark. Thanks for having me, and hi, everyone.
I want to start off pretty high level because, well, I think we've all probably seen things around our open source supply chain risk, and one of them, I've seen this statement or other statements like it saying that 85% of our code isn't actually our own code. And the first time I see this, I think that sounds strange. Could you maybe explain, like in the context of open source supply chains, why this statement is true?
Yeah, well, basically, when you or your company build an application, you usually rely on open source packages. Why? Simply because you want to make sure you do not spend your time reinventing the wheel, and like you want to write specific application works. For instance, you don't want to reinvent the component that does that. You want to interact with a database. You don't want to reinvent the driver for this. So basically, these libraries have been developed by the communities, and they already address specific functions, and you don't want to do that again. Instead, you want to make sure you invest your time in creating the value you want to create, or the benefits you want to provide to a group of users or companies. And yeah, if so, alone these dependencies do not provide much value, but combining them and adding your secret sauce, I would say, this is how you end up having 85 of your codes, not yours.
Yeah, I get that, and I think we can kind of understand, when we're creating projects, like I mostly code in Python. You import your projects, your open source libraries, and they certainly help a lot. But when I think about this, I think about the coding practices that we have at Guardian, and lots of companies do. Is we're very stringent on code reviews, on the tools that we use to ensure high quality. We even have lots of guidelines around formatting and and everything like this. And the idea of that is that we can understand really quickly, vulnerabilities in our code, or if it's introducing anything. If 85% of that is outside of our control,
Well,
does
yeah,
that create a pretty big risk for us?
yeah, it is. But we, as you said, we usually trust more open source dependencies more than we trust our own code. As you said, we have very thorough internal verification of what we develop. You have code reviews, merge requests. So lots of people reviewing what you're doing, ensuring that what you develop actually does what was meant to be done. And you have QA, CI/CD that make sure you don't break any policies or introduce any regressions, etc. But it's also partly true for open source. And it depends on the maturity of your organization, obviously. But you can also perform a few checks on the CI/CD related to the open source dependencies. So yes, it's we usually blindly trust the packages we download, but at some point it's also a bit tested down the line.
Yeah. I want to dive a little bit deeper into this, and I have a graphic to kind of help us out.
Mhm.
We have this, and I think a lot of people have seen this meme. And if you haven't, well, you're in for a treat. It's fantastic. But this is kind of just depicts the modern infrastructure. Then down the bottom it has a random project. Someone from Nebraska has been thanklessly manning since 2003, and is holding so much of this up. Is there truth to this? Can you kind of maybe elaborate on if this has actually happened and the stack has fallen over in a way, metaphorically speaking?
Yeah, yeah, it's a funny meme, but yeah. It pretty much gets the essence of it. We build complex infrastructure, complex applications, and sometimes we rely on some random project, or even not random, but with just one package managed by one maintainer. And suppose that, for instance, this maintainer have his account breached or hacked, then some attackers could, get access of his account and push some malicious code in his in these specific packages, and you would infect your own application just by trusting this blindly. And it actually happened for a specific case. I don't know if you heard about the UA parser example. So basically, this random person was someone named Faisal, and his account got hacked. He didn't implement MFA, I guess, and yeah, his account was basically for sale on the dark web, and yeah, that happened.
Yeah. So as funny as the meme is, I do like that. It paints a very accurate picture in here, and that this is actually happens.
Yeah.
But let's take this to another level,
Yeah.
because I mentioned we've been talking about open source dependencies, and you have an application, and to a large degree, you are in control of the dependencies that you first introduce, right? So you select what they are. You can vet them. You can see that there's a community there. Well, but what I think a lot of people perhaps fail to understand completely is that those dependencies also have dependencies, and those dependencies have dependencies. And when I look at this, I kind of think that there's a significant amount of control that we don't have around this. Is this really kind of true to the extent that we have packages that perhaps we don't even know we're reliant on?
Yeah, definitely. In fact, your slide is pretty much expressing it. We have dependencies, and these dependencies rely on others, which rely also on another layer of dependencies, sometimes the same. And so, yeah, you have several layers of dependencies, and as you mentioned, you could be out, I mean, of control if you don't have any specific tool to manage your these dependencies, and specifically your open source dependencies. So yeah, I'm thinking about software composition analysis here. You usually use such tools to ensure you are in control of what you have in your code and your application in the end.
Yeah.
And yeah, and I think what we don't see here is you have so much more complexity. I assume here is on the paper it's quite simple, but given we also rely on third-party services. Yeah, thanks. Yeah, you anticipated that. So yeah, you also rely on third-party services, and you can these services also rely on probably the same open source dependencies as your application. So yeah, yeah, exactly. It ends up like the software spaghetti, as you I like this.
Yeah, I love this. I love this graph because it really kind of shows that at the start things are neat. I pick my packages. They have lots of stars. Good community. I'm sorted. And then slowly you unpack it, and you understand that the level of complexity is is actually quite deep. But what is the risk here? I mean, if we take one of these packages down here, let's, I don't know, for chance call it log4j or xz, if we want to be topical. If one of those packages gets turned malicious, can that have upflow effects on us, even if we haven't explicitly using that? Can that infect upwards of the supply chain?
Yeah. In fact, because for instance, as you said, we don't use log4j directly. Let's take log4j as an example. But because we are using a specific dependency that reference another one that reference that log4j dependency, then our application would be infected by this vulnerability. And looking at the whole diagram, we can have also third-party services using the same log4j dependency, and also affect our application, by extent. So yeah, such vulnerability can affect lots of services, lots of application, and yeah, it can infect yours in many various points.
So let's talk about this infection now, because I hear a couple of terms thrown around, CVEs. Can you explain what a CVE is, and perhaps how that's different to a risk that we see elsewhere. A malicious package, a CVE. What's the difference there, and are there differences in the risks that they can pose?
Yeah, in fact, as you said, we have two main different of risk, two different risks basically. You have the CVEs that you usually traditionally follow and know about, and these are unintentionally um, vulnerabilities that could be exploited in production. Uh, Most of them are not, thankfully. But and on the so you have the typical CVSS score, EPSS score, and so on to measure the severity and the exploitability of such vulnerabilities in production. And on the other side, you have malicious packages that are designed basically to harm organization and the industry in general. So in the end, CVEs could be maliciously exploited, but it's not designed to, and the malicious one are designed to.
So, we've talked about Log4j, and as I understand it, this had a severe vulnerability in it, but it wasn't intentionally put there. But there is the other side of it where you've talked about where packages are intentionally turned malicious. And the other example that we have, about this that we talked about is XZ. And I just wanted to kind of ask you, like, how do these actors, how do these hackers, how do they actually turn these packages malicious, especially if they started life as legitimate open source projects?
Yeah, the XZ example is very interesting because it started with social engineering. Basically, the attacker started to contribute on this package, the XZ library, uh, and he contributed legit commit, sorry. And at some point, he made the community, push the maintainer to merge his commits. It lasted for almost a year. And at some point in January this year, he became a maintainer of the package. And he continued his contribution to the dependency. And in March, for his last contribution, he inserted malicious code. It was actually a backdoor, so pretty malicious. And it was only discovered by some employee at Microsoft running, some performance test on his application, and he didn't understand initially why his application was running slow. And he discovered that it was specifically because of that dependency. And yeah, he discovered this backdoor just by doing performance test. So he discovered this, I think, something like 2 or 3 weeks after the code was malicious. And you can imagine that if we didn't knew about it right now, the whole industry would be infected. So yeah, the blast radius is very high.
Yeah, it's incredible, and it's incredible to think about the sophistication. We're talking about years, spent crafting this. So, we're not up against kids in hoodies and basements. We're up against very sophisticated operations
Yeah,
that are willing to invest lots of time into this.
I think, yeah, one thing important to mention here is we industrialize the way we manage our applications, but I think on the other side, attackers also industrialize their attacks. So yeah.
Yeah. All right. So I want to dive deeper into this a little bit now. I know we've already kind of gone pretty doom and gloom, but there's been lots of ways that attackers have kind of targeted supply chains before, perhaps a little bit less sophisticated ways. Most people are probably familiar with the concept of typo squatting, where you take a popular package and you misspell it. XZ becomes ZX, for example. And you hope that some people will make this mistake and then inject a malicious package. But it's a spray and pray kind of hope. But as you said, we've industrialized the process. So these methods are getting industrialized, much more sophisticated. And there's one that's fairly recent that I want to talk about called dependency confusion. Can you elaborate on what dependency confusion is?
Yeah, sure. It's an interesting concept. So let's assume we are both developers at Gecko Island, and we have that let's say GG or some library that does some specific operation that we want to integrate in our application. So instead of inserting this dependency directly in our application, we just give a reference, a link to the library. So our dependency manager will look for the library and downloading this directly in our application for us. And the thing is, dependency manager will usually look for the public repository registry where the lib could be by default, or if the version is higher than the one located in our private repositories. So assuming we have a package with the same name, which is publicly registered, but not publicly registered by Git Guardian, let's assume, for instance, it would be an attacker. Then he knows about our GGAwesome library. It will publicly register that GGAwesome because we didn't do it. And he would, insert some malicious code. And if nobody is in Git Guardian sees the problem and sees the trick, then we would both actually download this dependency and would execute this malicious code directly on our environment. So this is the concept.
It's really interesting. So what you're saying is that if you have internal dependencies, not intentionally made public, that or no, intentionally, not made public, they're private, and if someone is able to find the same name as that and register it in a public public registry with a higher version, for example, then it's going to pull that version from the public registry by default. That's the setup that is.
Yeah, exactly. In fact, the dependency manager are usually by default looking for public registry first, and will look for higher versions because the logic is quite simple. If you think about the open source dependencies in general, you might want to look for higher versions that are maintained by the community. So in fact, by default, you would like to look for this public registry first. But for your internal private dependencies, if you don't change that configuration, then you will have the same pattern. You will look first from the public registry, and you will actually use this before your private registry, even though it's private.
Wow. So yeah, I mean, you can really see the complexities that we're getting here, but also that's it's simplistic in its nature. That if you have a a version online, it downloads it the malicious version. There's other kind of attack paths that have recently come up, and they're of course quite different, but I think that they share some of the same DNA. And I'm kind of referring to some of what I've heard about the AI and packages and risks there. Can you maybe share, how is AI kind of affecting the game? I mean, of course, it's 2024. We can't have any kind of discussion without at least mentioning AI once. So if it's on your bingo cards, you can click that off now. But I'm going to ask you, how does AI start to play into software supply chain risks?
Yeah, so actually, lots of, it's quite popular these days. Lots of developers are using it, and not only developers actually. So because I'm sure you also use the AI by yourself. You can ask AI pretty much anything you want, and you can even force him to say pretty much anything you want and something wrong actually. So if we think about dependency confusion and type squatting, it's usually the same. It's different concepts, but it uses the same pattern. So basically, a malicious actor publicly register a package, and he just bets on either the private name of our dependency, or he can bet also from AI hallucination. So basically, if you request the AI to generate you a package to connect, for instance, your Node.js with I don't know, for instance, NanoArongo and you ask AI to provide you with a package that does exactly this, then it will provide you an answer. So it will provide you exactly this as you show. It suggests you to do a npm install NanoArongo because you asked the AI to provide you with a lightweight package. So we assume that, and because you use the Arango name, so providing lightweight package for him for AI, it's just okay. What is the lightest version of Arango I could provide? It could be micro, it could be nano. In this case, he just came up with nano. You run that, and if you go on npm, I mean, yeah, you even have the slides. Brilliant. So you would notice that this package doesn't exist. So in this case, let's again assume that malicious actors know about that specific answers from AI. They could publicly register this nano Arongo that doesn't exist and turn this code malicious to execute remote code from your environment. So it's again the same concept, and just using AI.
Yeah, and it's very interesting how a lot of these kind of come with the same DMA, but they have very different paths to get there. We've talked a lot about doom and gloom, and hopefully everyone's not too depressed. But there's a lot that can happen in the open source supply chain. It's fraught with danger, as we've just kind of gone through. But let's talk about the positives. Let's leave everyone here with some actionable steps. How can we actually start to solve some of this? How can we ensure that we're using good dependencies? How can we know when they're turned malicious? How can we know if something's being hallucinated? Do we have options? Are we doomed to kind of be in the passenger seat of a car crash?
No, it's a very interesting and very complex question. So yeah, if we look about dependency confusion in general, I think the first good advice to share is it's also a good practice. Like if you have private dependencies, just make sure you register them publicly. So at least it prevents that to happen. No one can publish your dependencies if it's already registered, basically. Make sure also you enforce the settings of your dependency manager to look first for your internal repositories, stuff like that. And in general, for to prevent you from vulnerabilities and supply chain attacks, I think the main advice we can share is to use a software composition analysis tool, because it will help you assess your risk exposure, basically coming from open source dependencies. List all the dependencies you have. It can also help you check for the licensing if you use like copyleft license, stuff like that, and helps you, at least have an overview of your risks. And if you want to go a little step further, you could also use these same SCA tools that provide shift left capabilities. So in fact, it's quite easy to understand. You just make sure you don't introduce new vulnerabilities, or at least new dependencies in introducing new vulnerabilities, because you as a dev, you are working on something, on a piece of code right now. It's easy to block you from introducing new vulnerabilities right now, because you can fix it or upgrade the version of the dependencies right now, and make sure you don't introduce and push this to the main branch and therefore into production. So basically, you can have the same approach for your CI/CD, making sure you run all the tests, and maybe at first in non-blocking mode and then in blocking mode, just to make sure that you don't introduce at least critical and high vulnerabilities in production. So that's mainly the thing.
Yeah. And some great actionable steps in there. But I think the main takeaway is we're not helpless, right?
No.
Some of this may be out of our control. We can't control if transitive dependencies get turned malicious, or downstream dependencies, however you want to call them. But we can control, when we find out about them, the actionable steps. We can control the types of dependencies that we initially introduce. So we have more control, but we have to be proactive about it. Would you kind of agree with that kind of statement?
Definitely. In fact, tools are not solving the problem just by its own. You need to have, obviously, policies. You need to have processes to make sure that you don't introduce malicious package. It may happen at some point, but I think I see the security and in general as a science of just putting obstacles in front of attackers, and the more obstacles you put, then the more cover you are. In fact, it's as simple as that. And SCA is just one thing. We just need to ensure that you don't provide too many accesses to different applications or to your CI/CD. I mean, yeah, it's a global process. I would say.
Yeah. Yeah. No, I totally agree. And yeah, there you go. Tools aren't the 100% answer. I think there's a lot of vendors that might fight you on that, but I think I wholeheartedly I agree. They can be part of the process.
Exactly.
They're not going to solve you from everything.
Yeah.
Hey, Pierre, I want to thank you so much for joining this discussion with me. It's been really fantastic. I've really learned a lot, and I've really enjoyed it. And for everyone listening there, I have exciting news that you can now answer questions. Pierre and myself will be joining live. Don't ask me any questions. Ask Pierre questions. It's going to be much better. No. But please feel free to interact in the chat now, and we will be standing by, getting ready for more questions. So we're going to finish it up there. So Pierre, one last time, thank you again. And don't forget to ask your questions.
Yeah, thank you, Mac.